In this video, we continue on with part 2 of our foundational problems, and we've got a make or buy decision now. We're told to assume that Kane expects to produce and sell 80,000 alphas during the current period, and that a supplier has offered to manufacture and deliver 80,000 alphas to Kane for a price of $80 per unit. If we buy 80,000 units from the outside supplier instead of making them, how much will profits increase or decrease? In terms of our costs, we need to consider only our direct or variable manufacturing costs, direct materials, direct labor, and variable manufacturing overhead. We'll still have to incur variable selling and admin costs. So the total differential cost of making them is $57 per unit, and the supplier is offering to sell them to us for $80. Our first inclination is not a chance, because if we compare those totals, we're going to have to pay an extra $23 per unit if we go outside. But if we quit producing alphas, we will get rid of some of our traceable fixed costs. So perhaps this will pan out. Again, we're talking about 80,000 units at $23 a unit. That's going to cost us an additional $1.8 million, or $1,840,000. But we're going to get to save our traceable fixed cost, which for the alphas, unfortunately, we're only $1.6 million. So do we want to go to an outside supplier? Not if we're talking about 80,000 units. We would be worse off by $240,000. How would our decision change, though, if we only expected to produce and sell 50,000 alphas during the current year? And again, the manufacturer is making us that same offer. Well, again, we need to look at our variable manufacturing costs, direct material, direct labor, variable manufacturing overhead, for a total of 57 compared to the $80 purchase price. We're going to have to pay an extra $23 per unit. And if we're producing and selling 50,000 units, that's a grand total of $1,150,000 in extra cost to go outside. But hey, we get to save what? Our traceable fixed costs, which were $1.6 million. So the net savings from buying from an outside vendor would be $450,000. So a question then is, at what level of sales would we be indifferent? It's simply a break-even calculation. We take the fixed costs, traceable fixed cost of $1.6 million, and divide it by our differential cost per unit of 23, and we see that it's 69,565 units. We would be indifferent. If we're producing more than that, then we would like to stick with production. If we're producing less, then outsourcing would make more sense. This is a rather myopic view, though, because this is basically a one-period decision. What we're really concerned about is longer-term sales. If we have cyclical sales, well, we don't want to suddenly outsource one year just because sales and production are low, if sales and production are going to be high in later years. But we would go through this similar exercise. Another problem with outsourcing is we might lose some of the technical expertise required to develop new products in the future, or to move into new product lines if the opportunity presents itself. So we would also have to consider potential future opportunity costs. And again, those could go both ways. We might have better opportunities to reallocate our current resources, or we might miss out on future opportunities if we quit producing alphas and just simply outsource them. The United States has certainly found itself shy and short of personal protection equipment during this pandemic because we've outsourced so much of that production to other countries, in particular China. So there can be a cost associated with outsourcing. Apple faces that potential cost all the time when we talk about imposing tariffs on goods imported from China, or complete bans on transfers of certain types of technology. We're now going to look at some problems involving constrained resources, and our constrained resource is going to end up being raw materials. So the first thing we wanted to do is calculate our contribution margin per pound of raw materials, so we could figure out which product we should allocate a constrained resource to first. And we're going to have to calculate our pounds per unit. We're given our material cost for an alpha of $30 per unit, and our material cost for beta of $12 per unit. And up in the given information, up here up top, we're told that our raw materials cost us $6 per pound. So we're using 5 pounds of raw materials to make an alpha, and 2 pounds to make a beta. Our contribution margin per unit of alpha was our normal selling price minus all of our variable costs, so it's $51 per unit. We take 5 pounds to make an alpha, which means every time we're using a pound of raw materials, we're generating $10.20 in contribution margin. For the betas, our normal contribution margin is $40 per unit, and it takes 2 pounds to make a beta. So we can see our contribution margin for making betas is $20 per pound. So if we have raw materials as a constrained resource, we're going to want to make sure we maximize the use of that constrained resource by making as many betas as we can sell, then moving on to making alphas after that. As you was expected and as I promised, we've come to our constrained resource question. Assume that Kane's customers will buy a maximum 80,000 units of alpha and 60,000 units of beta. Again, remember, beta, we have a higher contribution margin per unit. Also assume that our company's raw materials available for production is limited to 160,000 pounds. How many units of each product should we make to maximize profits? Again, we start off by making as many betas as we can. We've got the 160,000 pounds of raw materials. We will allocate 120,000 pounds to making betas. 60,000 units is our demand at 2 pounds per unit. That will leave us with 40,000 pounds that we can allocate to making alphas. And alphas require 5 pounds, so we will make 8,000 units of alpha. So if we follow that recommendation, what's our total contribution margin? So again, first thing we're going to do is crank out 60,000 betas, and we had a $40 per unit contribution margin, so we'll generate $2.4 million. The rest of it we were going to allocate to alphas. Our contribution margin on alphas was 51. We were going to make 8,000 alphas for $408,000 total contribution margin. And our total combined contribution margin is $2,808,000. That's our optimal allocation in terms of a product mix. No break-even or no constrained resource problem would be complete without the opportunity to obtain additional units of that constrained resource. And so our question is, how much would we be willing to pay per pound of additional raw materials? Recall our current price per pound is $6 per pound, and we've made all of the betas that we can possibly make. So every additional pound will be allocated to making alphas, and our contribution margin per pound was $10.20. So we would be willing to pay an additional $10.20 to obtain additional pounds of our raw material, a total price for those raw materials, of course, then of $16.20.